Our last topic is autoencoder, a neural network model. Autoencoder has three key components. The first one is called an encoder. So this is the encoder. It basically compresses data and extract features. You can see the dimension is reduced. So it is a dimensionality reduction process over here. And we also have a decoder, which is to generate the images given a new code. That is, the decoder over here takes the code here, a low-dimensional representation at input, and generates a high-dimensional output. Okay, so then what's in the middle is the bottleneck or the code we have been generated, right? So that autoencoder generated code, which is a bottleneck. And in order to make this autoencoder non-trivial, the code over here needs to have a much smaller dimension and used as the latent representation. So this is a low dimensional representation and it can be used for dimensionality reduction application. So here is an example for autoencoder on the CIFAR10 images. And here is the input vectorized image. And the first layer use 500 neurons. And the next one have fewer 250 neurons. And the code is simply only 30 dimensional. It's only 30 dimensional. And then for this is a encoder. This is the encoder. And for the decoder, it is in the reverse way. Right? We have the 250 neurons first, then 500, then the final output is basically a reconstruction of the input. And then we compute the difference between reconstruction and the original input, and this square difference serves as the loss to optimize, to minimize, right? And the objective is basically to find the ways for these neural networks to minimize the difference between the input and the reconstruction. So here, the code layer, the bottleneck, becomes a low-dimensional summary of the input. We can actually view PCA as a linear autoencoder. So PCA can be viewed as an autoencoder with single-layer encoder and single-layer decoder. Right? So such as this, right? So this is the input X, and the encode we use the rotation matrix transpose as an encoder to generate the representation in the output space. Right? So that is basically the code. And in the decoder, it's basically using weight sharing. Right? We can consider it as weight sharing between the encoder and decoder because it uses the same weights as the rotation matrix, but without transpose. Right? So this can help us to reconstruct the input, right? So in the output layer. So the objective is to minimize the reconstruction error. So this interpretation takes the reconstruction error minimization or derivation of PCA. And to build this autoencoder, we need a transpose convolution layer covered in the last lecture. So this is a traditional convolutional layer where the output is typically smaller than the input. And in transposed convolutional layer, through zero padding, we can have an output of size greater than the input size. This is good for reconstruction. So it's a transpose convolution layer. So here is a convolutional autoencoder used in the lab. Right? So there are other type of autoencoders that are not convolutional. So this is called convolutional autoencoder, has three convolutional layers and then three respective transpose convolutional layers. And it is the convolutional autoencoder to be used in the lab. And for the training, it is just a standard neural network model training. We do the sample of a batch and then do a forward pass, compute the loss, the error between the reconstruction and the original image, and then iterate to do the optimization. So that's autoencoder. Right? So it is a neural network defined as layered networks, layered neurons. And the hyperparameters are typically the neural network layer hyperparameters, like such as number of layers, number of channels, and the kernel size, and the number of nodes, neurons in each layer. And we learn the new layer weights and biases as a parameter. And the evaluation metric is a mean square error between the reconstructed output and the input. And optimization are typical neural network optimizations through back propagation and gradient descent. So as usual, I thank the following researchers for sharing their slides. And these are some recommended readings for the PCA book. And most machine learning books has a chapter on PCA and clustering. And the normalized card paper is, I encourage you to read if you are interested. And there's a chapter on autoencoder in the deep learning book. And as usual, you are encouraged to look at the Wikipedia entries and scikit-learn and PyTorch documentations and so on. All right, so that's the end of this week 8 lecture on unsupervised learning. So next I will give you a brief discussion of the lab notebook, and I will follow up with some feedback. That's all.